Good morning. My name is José Bonfim from FCT, and I'll be the moderator of this session. We have 6 communications. Each will take 10 minutes, with plus 5 minutes for discussion. Okay. At the 6th minute, I will show the yellow card. And at the 10th minute, 10 minutes, the red, with discretion, of course, I will have no whistle. We have, as you know, 6 communications. The first one focusing cloud-based technology, the second one on collaborative cyber-physical systems, the third on Internet of Things networking architectures, the 4th around the collaborative robots, the 5th nanotechnology Zoom in a clean room, and the 6th on cyber security. So we'll start by the first one. Is presented by Centro de Informação, Tecnologias e Arquitetura, from ISCTE, and the authors of these communications are Ana Maria de Almeida and Carlos Serrão. I do not know who presents. Okay, welcome. So you have 10 minutes.
Okay, thank you. It's okay. Good morning to you all. I'm, of course, Ana Maria de Almeida, and I'm here to present a joint collaboration project between academia and an enterprise, ISCTE-UL and Aptoide, and we're building a cloud-based anti-malware technology for Android application called App Sentinel. So I'll briefly present the organizations behind this collaborative project, our main motivation, the main concepts and object of research, and how we plan to do it, or are doing at the moment, and what's our goals. So ISCTE-UL, it's a research center for ISCTE-UL, Instituto Universitário de Lisboa, and its main competencies lie in computer science and information technologies, mathematics, mainly applied to computational problems and complexity, and architecture and urbanism in all its digital dimensions. We are collaborating with the other half of the team, where the majority of the research students that are collaborating in the project are working. It's a Portuguese SME called Aptoide, and it reaches the international market, and its main product is a mobile marketplace. And they were the proponents of this research project that is being funded under P 2020. So what's App Sentinel? We intend to develop a cloud-based technology directed for Android application stores, aiming mainly to build process for preventing security breaches on mobile devices before they happen, and also enabling a quicker reaction to new mobile threats. In fact, mobile devices are quickly overtaking home devices in the number of users. It's estimated that more than 6 billion smartphone users will be there by 2020, just next year. These devices are basically replacing personal computers, both at home and in the workplace, and serve for everything from web surfing to e-commerce to online banking. And so securing these devices should be a top priority, both in business and in personal use. Out of the 2 mobile platforms that actually dominate the market, Android and iOS, Android is the most popular. It's currently ranked as the operating system of nearly 80% of all mobile devices in the world. Being the preferred platform is also the preferred platform for malware authors to instrument their attacks. And we are witnessing an increased influx of malware applications that target directly Android application stores. malware or malicious software, we are used to think of it as a threat to laptops and desktop computers. But as we are moving more and more into a mobile environment, cybercriminals are targeting smartphones and general mobile devices to a far greater extent. The threats are not new, but they are targeting mobile devices. Of course, that Apple and Google have taken preventive measures to prevent malware in their platforms, but nevertheless, malware is still having an impact on these devices. And the threat vector is increasing exponentially as these mobile devices are used more and more to make payments. Digital wallets, technology allowing business to accept mobile payments have acted as magnets for cybercrime. And the traditional security flow is now being unable to anticipate or quickly deal with these threats, mainly because applications are being developed by the thousands by day, and so detection of new threats, it's a long process, and it makes it a successful process to use malware. In fact, the high impact is due to the fact that currently, the actions against malware only occur after a significantly large number of attack reports are made from users. And this assures the malware success over at least some period of time that allows it to potentially reach millions of users. And a big issue here is that there are numerous situations where the lack of good software engineering practices turn innocent applications, which are now being submitted to Android application stores, which are not a threat in themselves, but they are easy targets for hackers to access the user's device and information. So, what's the main object of study of our project? Are the applications themselves. Applications for Android are developed using the Android software kit, and most often the Java programming language, although there are already other developing programming languages. Being a very open and adjustable platform, there's a growing selection of third-party applications which are acquired by users, which are then downloaded and installed in the application using the application's package. The application package, or APK, it's a file format that Android uses for distribution and installation of their applications, containing all of the program's code, the application code, the resources, the assets, a certification, and the manifest file. The manifest file describes all the key information about the application to the Android building tools to the operating system. And besides the name, of course, it includes all the activities the application is supposed to do, services, broadcast receivers, content providers, permissions for the application to access protected parts of the system, and of course, hardware and software features that are required. An example of a manifest file can be now seen in the slide. And this is the threat. This is the target of our research. Because Android applications, even being in itself harmless, they grant permissions that can access most of the sensitive information that we store in our telephones or use our telephones to make business or deal with. So mostly applications can be especially developed in order to steal the user's information, but more and more they are being replicated normally in paid applications and being replicated and expanded to ensure that they can be used as malware once they are offered as cheaper prices or even for free. How can we secure our applications? Malware detection nowadays uses static and dynamic analysis, or both, to detect malicious software. You can think of static analysis as you do when you're spelling and grammar check a document you are working on. This analysis ensures that you're using correct structure in your sentence or paragraph in the code, and make sure your periods and commas are where they need to be, and the spelling and grammar is okay. So besides these parsings, or this parsing is effectuated so that standards look not only at code security, of course, but also code quality, which is very important to divulge and replicate best practices, and also to sniff bad code. Dynamic analysis, on the other end, is commonly performed by looking into system calls and API calls, which must be done by executing the application, which is, of course, done in a sandbox environment. So I must hurry, but I'm coming to a conclusion. Our project is built under or in multiple dimensions, but mostly it uses machine learning to understand the malware patterns or the vulnerability patterns of code, and to identify possible vulnerabilities or effective malware before they are delivered to the users. And we can even, in case of vulnerabilities, report back to the developers and help him correct them. So we address the problem as that application stores should incorporate proactive and intelligent malware mechanisms themselves, given that they hold the privileged position between developers and end users. So what we're working on, we are working now at this automatic learning system that uses both static and dynamic malware and code smells, so that we can build an intelligence classification system, but also to provide rules that would help further development of applications, and on the other hand, profiling algorithms as being malware, not malware, malware vulnerable. And the greatest dimensions for us is also the providing feedback back to the developers. We think this is a major keystone also in our project, not only the automatic system for automatic detecting the malware before it is delivered to the users. So that's basically what I had to present for you today. If there's any questions. Thank you. Well,
Yes?
Alguém tem questões?
I'm not an expert, but I can say that new threats are always successful.
yeah, because the traditional malware detection systems are not that good, especially when it comes to bad coding, and so open up the backdoor doors for hackers to explore after the application has been delivered. And that's why stores rely mostly on reports of attacks, and only when they reach a certain level of alert, they can try to react. So this takes time, and that's why we're trying to prevent this before the application is delivered for usage.
Another question is, you mentioned on the very last slide that automatic system capable of analyzing users' feedback.
Also, yes, we don't stop when we analyze our application and deliver it. We wait for user feedback that it can help us improve or detect undetected things, and use this new knowledge into the system again, so that it keeps learning and adjusting to new malware threats. Yeah, it's quite difficult. Okay, thank you.
Now we move to the second communication by Luís Camarinha de Matos, José Barata, Luís Gomes and Paulo Graça from Centro de Tecnologias e Sistemas. The title is Collaborative Cyber-Physical Systems in Manufacturing. I think it's Professor José Barata, yes?
So, good morning, ladies and gentlemen. So, I hope that I can at least get your attention to this subject that we are bringing. We have here a diversified audience. I try to keep the focus on what is really our message. So, what we are from, as Jean-Benfin said, from the Uninova Center of Technology and Systems. This is a research center belonging to the Nova University, Faculty of Science and Technology, and together with some companies. So we are a diversified group, and making hold our research together sometimes is quite a challenge, and Professor Camarinha, that is the responsible for CTS, tries this hard, and this is just an example of the putting different groups working together in this area. As you see, we are the presentation is about the work that we are doing that is collaborative cyber-physical systems in manufacturing. And about the CTS, one very important thing for us is that, and this was work that we have been doing, trying to frame and put a basis for our work. You see that we can see different framework levels. This is about cyber physical systems, but you can see we have the different levels. You have the smart device, smart sensor, the lower level. Then we have the intelligence on top of it. Then the systems of systems, when we have this integration of the different systems. And we have, in my opinion, one important aspect that is these cognitive collaborative systems. Because at the end of the day, what we want to express is that there are some cognition, some high-level intelligent aspects that are on top of systems, and all the work that is been doing in collaborative networks, in collaboration, is here, because collaboration between people, between machines and people, or between people and machines is an important issue. Then you can see that we also have different application domains. Manufacturing is just one example that we are working. We are working in energy. Sorry that sometimes I have to look at that because my eyes cannot really see exactly reading, so the sound goes a bit down. But health and care, space industry. Then you have the different technologies, because what we really want to understand and is making some scientific rigor on this, and for all of us understand exactly where we are. For instance, intelligent robotics technology, data analysis and decision support, collaborative networks technology. So myself, Professor Camarinha, for instance, collaborative networks, myself is more in intelligent robotics, but then we have the people from embedded systems. So I'm just spending some time on this for you to understand exactly the area and the areas that we are covering in our institute. So now let's go a bit to this issue of cyber-physical systems and this Industry 4.0, that even now we cannot avoid from this word. I have very nice discussions with Professor Camarinha because he hated the Industry 4.0 name, but because what we are talking here is about smart manufacturing. But sometimes when we deal with people, if we do not use the words that they are used, forget, they will never listen to you. So we use the word like the young say, yeah, meu, things like this. So it's the very easy way to start a communication. So in terms of Industry 4.0, anytime I see this picture, I'm getting a bit I still have some little hair on the back, so, but even then I can lose them. Because what is here is something that started long before, because the Industry 4.0 and all these aspects of modularization, all the aspects that are related exactly with the concept of cyber-physical system started long time ago. Okay, okay, this makes simplifies a lot for the people and also to sell the number 4. But then, okay, what is clear in the Industry 4.0 smart manufacturing is the existence of cyber-physical modules that are simultaneous mechanical, electrical, and informatics. And this is what, in fact, the way we see all our systems. Really, if you can lose some time in this picture, in this slide, is really very important because it shows you the different levels, dimensions of the fourth industrial revolution. And then you can see the integration of the infrastructure with the product. If we go, for instance, for the RAMI, the reference architecture model for the Industry 4.0, you will also see these aspects of the infrastructures, the different levels, but the product inside. And this is very, very important issue. And then you can see, for instance, for product, what you have, the through engineer across the entire value chain. So this immediately brings to you the idea of collaboration at different levels that I hope to show, that I have time to show you some examples. Then you have another in the product, the digitalizations of product and service that everybody talks about. Then the new business model. But look at infrastructure, vertical integration with the different levels. If you look at this picture, somehow you can see some of these levels here. And then you also have the horizontal integration that you see, collaboration again, transparency. So means that when we are talking about cyber-physical systems, of course, one important aspect is the lower level. How do I create an entity? And then how I put these entities collaborating? And then how do I put from a factory? This is a line, then I have different lines that create an enterprise, and then all this enterprise connects with the other. Yes. So your time is not so good as mine. Mine is slower, okay? So when you look to this picture, what you see, again, is the emphasis in this vertical thing. You see smart device, intelligent systems, and then the collaborative networks. Ladies and gentlemen, I could say much more, but now I will speed up a bit because to show you some of the demonstrations that where we are working. So there is no cyber-physical systems without hardware, without the lower level. So with this work, we are using these input-output place transition nets from the Petri nets, where this is a web tool where we create the code. You can generate code for FPGAs, you can generate code for PLCs, you can generate C code that can be used in there. So the idea is for these lower level controls. Then we can have here an example where you use something that was developed with that tool, then using your brainwaves, and then you control a UAV. Important aspect here is the control that you can make debugging online, and this is an important issue. But another area, this has to do with exactly my own area, is the use of, for instance, we are using and developing cyber-physical systems for different manufacturers. Electrolux is an example, and this is the example of applying these ideas, and in particular data mining and machine learning, to extract information about energy saving. And then Electrolux can choose, can optimize their scheduling in terms of what machines can be used for which products, and so improve a lot their products. Then we have another example of dynamic scheduling that was developed for Siemens, where we are using again these ideas of cyber physical system, but then we are extracting. As you can see on the right side, we are extracting and using data mining to optimize the production scheduling. So the next thing that for me is also very, very important is that, as we see, remember that we have on top this cognitive collaborative system. If you look, a very important work already with many years that has been doing is trying to find, for instance, a taxonomy of collaboration. What is these things of collaboration? Because, and this Professor Camarin was very, very detailed in trying to understand difference between collaborative networks organization, what is a virtual organization, what is a virtual enterprise, because all are these aspects that are important. And you see, we have these virtual business environments that where you can have different entities that can create virtual organizations or temporary alliances, if you want, to solve certain problems. And so there is a lot of work, for instance, on value. What is the value of, what values exist in an interaction? How important are emotions? We are humans, we know very well how emotions are important. So these are aspects that have been detailed. Finally, also in relation to this, and for me is the very interesting work, is using the performance indicators to understand how collaborative business ecosystems work. So the idea is that one important aspect is that we really adapt to the way we are valued or evaluated. So this is basically the idea behind it. And when you can understand what is really important and what can lead you towards a better performance, then you have really a strong tool. I'm going to the last slide, okay, sorry. So, conclusions. First of all, I hope you got my message, okay? And what we really tried here was to pass this idea that we have modules that we put together and they interact. So cyber physical systems are fundamental transforming factors. They are the basic building blocks. And the interaction, in fact, is the collaboration. And all these, in my view and in our view, makes what is called the smart manufacturing. And we need really new engineering solutions exactly in the design and this in the engineering design and operational phase. Thank you very much.
Questions, please? Comments?
So,
Before any question, again, not in an expert, but from general public with scientific culture, I would say that physical systems are more. Thank you. People are more acquainted with application in, as you mentioned, in industry, and you mentioned also in energy, but concerning health, space, and the smart cities, of course, it's very well known. How about the impact of application in, as you mentioned, in health, space?
yes, look.
You have no time to mention it.
I would say that is in fact real transversal, because what you want to do, the problem of the systems of today, forget if it is agriculture, manufacturing, or health, or space, is you need systems that can be easily changed, that can easily adapt. And adaptation is not only at the individual level. I always love this example. If I have this hand, but if I could change my hand, for instance, when I'm screwing my TV that broke and I want to screw, I would love to change my hand and put a Black & Decker screwdriver, okay? Because then it would be much easier. And this point means what? You are really supporting transformation. And with transformation, the basic things is using this cyber-physical. Why? Because you have the local intelligence, and then basic on the building blocks, you can create complex structures, whatever they are. Of course, you have the problem is that when you plug module A with B and C, what you get? People from biology, people from chemistry knows very well what is this. Put hydrogen with oxygen, what you get? That's it. So, and these are the different basic blocks that I'm talking here. So, answering your question, obviously, is exactly the same.
Thank you. From the audience?
I was not able.
You mentioned also the acceleration of manufacturing. By that you mean...
Accelerating. The problem
really
is...
acceleration,
Yes.
speed.
The speed depends what speed we are talking about here. Is the speed of transformation, of changing. Because remember how many years the carrocha is the Brazilian term. How many years the Volkswagen, the carrocha, was in production? 40 years? How much your car now? Look at Volkswagen Auto Europa. They change the models, not the big model, but they lift every 3 years. So how do you change this? If you do not have an easy way to plug and unplug, forget. You do not have the sufficient money, and you still want quality, and you want lower prices. That's the point.
Thank you so much. Let me remind you, for those who do not know, for sure, that FCT is with the support of experts drawing a thematic agenda on cyber-physical systems. Yeah. It is delayed, so it will be relaunched, the work by September. Yeah. And of course, you are invited.
May I say something?
To collaborate, if you so wish.
May I say something? Look, even traditional sectors, I'm now involved in a collab that is of course, some marketing here, Smart Farm Collab, that is about digitalization of agriculture. Look, it's exactly a good example of use cyber-physical systems, because at the end of the day, the problems are the same. The thing is, and the Agriculture 4.0, because you are from the Fundação, is important for people to understand this. One thing is, the people in agriculture is living exactly what the manufacturing was living 15 years ago, when these ideas started. It was people, I remember that we were in the middle of a project called Evoa Ultra Precision Assembly System, and the guys of Siemens, Philips were saying, but how can the factory be self-organizing? The factory will decide to produce their own products? My friends, we are not talking exactly about the factory getting themselves and producing what they want. We are really talking is how can you self-organize in the right direction based on what you want? And these different perspectives sometimes can kill the revolutions. Thank you.
Thank you so much, Professor Barata.
Okay. Bom dia.
Please.
Good morning.
Good morning.
We are here to present our COPLabs, our unit, our research unit. I'm Daniel Silva. Here, José Soares and Liliana Inocêncio. We are researching COPLabs, and we are here to present a little bit about our ongoing work and talk a little bit about the Internet of Things and new Internet edges. Our advisor is Professor Ruth Sofia, and he is also part of our team. So today, the Internet of Things is already a reality. We have sensors around our cities, in our cars, in our home, and these sensors are collecting data and send this data for the cloud, for instance, to process and storage data. These data are being transmitted to the cloud to be processed, and today, the Internet of Things is a cloud-based. So we are using the cloud to do that tasks, to the processment, the storage. We have two different scenarios for the Internet of Things. We have the industrial IoT and the consumer IoT. The industrial IoT is more about machine-to-machine communication in our factories to manufacturing products. And the consumer IoT is more about people, devices, and people. It's to improve the daily routine of people. So in the consumer IoT, we have the personal IoT. The personal IoT is what it's sensing and collecting data from people. And in these two scenarios, we have some edges. You have to add mobility, you have the issue of the mobility, and the Internet of Things is bring. The Internet of Things brings some challenges and some opportunities in terms of the network. So mobility is one of the issues you have to handle. And so in these two scenarios, in these two pictures, you have two different scenarios. One is autonomous drive system. So in this case, we have cars, we have sensor in these cars. This data from cars are being transmitted to a station or another cars. And these cars and the stations and the cloud, they are devices. And this we call the edge. So a car can be an edge, and a central station can be an edge, or a sign in a traffic system, for example. The other example we have is ambient assisted living. So we have a person with sensors, with a smartphone and a smartwatch, or sensors embedded in some hardware. So we have the smartphone, we have gateways, we have access points. So all of these devices can have the capacity to process data, to storage data, and to transmit data. And that's the idea of edge computing and fog computing. Use this device to improve the network functions, not only use the cloud. These edges and these edge devices, they have different ways to communicate with each other and with the cloud. And there are two main consortiums to create standards for these not only the Internet of Things, but the Internet. And we have the Internet Engineering Task Force is from US, it's American consortium. They are working on IPv6 and improving the standards for CoAP, the protocol of communication, CoAP. And they are working on security and mobility also. Here in Europe, we have the European Telecommunication Standard Institute. They are also a consortium, and they are working in interoperability. That's the reason, it's one of the keys for the Internet of Things, because the devices have different ways to communicate. And also we have the Industry 4.0. It's not a consortium, but it's an idea, a revolution of, it's based also in communication, in connectivity. And they are working and they are improving some protocols of communication like OPC-UI and DDS. So the interoperability is one of the big issues you have to face. And that is the idea, or where we are looking for edge and for computing to reduce the cloud, the use of the cloud to improve the network. So in the Copy Labs, we have an IoT lab, we have a test bed with a set of sensors and a set of devices, smartphones and computers connected in a Wi-Fi network. And we are exploring, evaluating communication protocols, named data network approaches. We can connect to other test beds like to get large scale, like Fit IoT, a test bed, a huge test bed in France. We want to understand better the pros and cons about information-centric networks and IP-based versus IP-based communication. And this test bed, this IoT lab, provide us to test and evaluate some systems, some protocols, and then we can improve the network, to try to improve the network. In this lab, we have some ongoing work, and I'm here to present a little bit about these three works, my work by myself, by José Soares and by Liliana. I'm working on contextualization. I'm using the context of the environment, the network, the device, like battery or process CPU capacity, to improve the network and select the best edge considering mobility. Liliana is working on large-scale sensing for the IoT, using also distributed mobile edge computing. And José Soares is evaluating protocols, communication protocols in our test bed and the Fit IoT test bed in France. Thank you very much. We are here to answer the questions, and we invite you to meet us in the poster session. We have posters with details about our work.
Questions, comments, please? You mentioned the lack of interoperability as being a major issue. Would you like you to comment a little bit on?
Yes.
Hello, I'm José Soares. I was working with testbed. I performed some tests with communication protocols, and one of the main difficulties I had while installing and testing the protocols was that, for example, with MQTT, which is a protocol for IoT communication, I had to use one client to publish, one broker to receive the publishes, and to accept subscriptions from the other client, which subscribes to the broker. So I had this broker called Mosquito, and it only supports communication over MQTT, not for other protocols such as OPC UA, for example. So if we had like another broker that could support multiple protocols, that would be easier. So to test both protocols in the same conditions, I need another broker or another server, something that works in the middle. So interoperability there would be great. I don't know if I answered.
It will be critical issue, yes. And thank you for being so strict with time. You also mentioned the latency sensitive applications in your slides. So this means the requirement of developing applications with more latency times to be more sensitive. Is this critical?
Yeah. In real-time system, the latency is critical. That's the idea of using the edge computing or use the edges in the network. We can process this data as close as possible to the end user to reduce latency and be close to real time.
Any question? Yes, please. Welcome.
Hello. My question is regarding the scalability of the system. If you already did some tests regarding that, for instance, and using the example that you presented with the cars, for instance, in a city like Lisbon, how many gateways you need to collect all the information around all the city and all the cars? I don't know. We can have 5,000 cars in one day in Lisbon, I don't know, 1 million.
Yeah, of course. We have in a system just like that, with a lot of edges and a lot of ways to communicate, the interoperability, it's an issue. And we can use each edge as a device to communicate. So you can put all of them in the same network to communicate with each other. It's not easy, we know, but it's already possible. We are using the test beds to evaluate that, and we can connect our local test bed in Copelabs with other test beds. Like I said, there is a huge test bed in France with hundreds of devices, and we can evaluate the protocols and the latency, the performance of the protocols in large scale.
But in that use cases, you process all the information on the edge level or at the fog level as well?
And we can process in the edge level or in the cloud, but this is very related to my work. I'm using the context to understand where is the better device to process. Sometimes you cannot process in edge because there is no capacity or for other reason. You have to send to the cloud sometimes. Cloud will not end with edge fog computing, but we can improve the network sometimes processing and storing data in this device.
Okay, thank you.
Thank you so much.
Thank you.
And now we have the fourth communication on the team from collaborative robots to sustainable business models, addressing systems of systems in industry. From Inesctec, the authors are António Lucas Soares, António Paulo, peço desculpa, Moreira, talvez, peço desculpa, Germano Veiga, Alexandre Xavier, António Azevedo, Ana Vieira e Pedro Amorim.
Thank you. So, thank you for the introduction. Hello, everyone. My name is Gonçalo Figueira, and this is a joint work with several people. As you can see, the list is quite long, and that's because at Inesctec we have been working with collaborative robots in multiple fields and with multiple teams. So the idea of this presentation is that I give you an overview of what we have been done in these different fields. So traditionally, humans and robots are seen as alternative resources, but more and more this is changing. So because they are actually quite different resources. Humans can do complicated tasks in a very efficient way, or at least they are complicated for the robots, like opening up a plastic bag is something that the robot cannot easily do. And also humans are more flexible and adaptive. And robots, on the other hand, they are stronger, they are more precise, and they are not subject to fatigue. So it would be quite natural that we try to combine the best of two worlds and we try to make them collaborate more. So what are these collaborative robots or cobots? These are robots that were specially designed so that they can work side by side with humans. Traditional robots, we usually have to put them aside. We have to put them with some fences to protect humans. But these collaborative robots were designed with safety features like force feedback and collision detection, so they can safely work side by side with humans, and in that way we can try to get the best of two worlds and try to improve the productivity of the final output and also the quality of what we are producing. At the same time, the idea is that we try to free the human operator from those back-breaking activities that can potentially be harmful or to the health of the human operator. So, this technology is quite promising. There's a lot of hype around it. Actually, there are some projections that tell us that in 5 or 6 years, we will have 10 times more collaborative robots than we have today. But beyond this hype, it's really important to understand, are we ready for that? Or is there still some work to be done in different fields so that we can bridge this gap between the hype and reality? So that's what we have been working on in different fields like robotics, augmented reality, machine learning, and operations management. So, starting with robotics, I'm not from the robotics, but my colleagues, they have been working to make this technology more effective, to make robots, because these robots are already successful in doing some tasks, but in some other tasks they are not yet precise enough, they are not fast enough, so they need to improve the way they sense the environment, so the force sensing, the visual sensing, so that they can move around quicker and be more precise also. In addition to robots, another key component of all of these concepts is the interaction between humans and robots. And for that, augmented reality is really important. So this is another buzzword of the Industry 4.0, but in this case it's really important because it will give instructions to the human operator of how to deal with a robot and how to cooperate with the robots. So besides projecting, as you can see in the right-hand side, you can see that we can project instructions for the human in the form of text or video, but we can also color different areas, so tell in the areas in red that the human should not touch those areas because the robot is moving there. And with other colors like green or blue, we can tell the human what to do next, where to go next, and where to assemble the next part. And finally, we can even project buttons, virtual buttons that the human can touch and tell the robot that the task is done and he can proceed to the next one. In this human interaction, so besides augmented reality, another very important tool is machine learning. And machine learning can be used in different ways in this interaction. Two of the main ways is to make robots predicting human behavior, which is sometimes not very easy to do. But if they are able to do that, they can avoid inefficiencies and they can adapt better to the environment. And also deciding in real time how to adapt according to these changes that are always occurring in the shop floor. So for instance, imagine that we have a different set of jobs to do, and we need to sequence them every time. So we can use very simple rules like shortest processing time. We will start with the shortest job and then go with the longer and longer and longer ones, or do the opposite. We will start with the longest and then move to the shortest. But these simple rules are simple and they are not very effective. So what we did in this case was to use machine learning to learn a new rule. Learn a new expression, which is a little bit more complex than the other ones, but it's still feasible to compute in real time, and it will be much more effective and robust in different scenarios. Okay? So according to this function, we are able to sequence jobs in a much more effective way. Okay, this is all about the operational level, so the shop floor, but when we talk to industrial managers, they are also very concerned with the more strategic levels. So, and they have two big questions that they want to answer. When and how? When is it worth to invest in collaborative robots? When is it worth to employ two resources, both a human and a robot, instead of just one? So in some cases it might be worth the gain of productivity, in some other cases it might not. So it's very important for them that we are able to quantify that improvement. and also how to do it, how to schedule these two resources, how to synchronize the two resources, how to optimize the scheduling, right? So to answer these two questions, we need optimization models. So we have formulated this problem. This is actually a new technology, and it has resulted also in a different scheduling problem that was not really that well explored in the scientific community. And we have seen, so it has this very complicated name. It's a multi-mode, multi-processor task scheduling problem. But what it is the following. We have a set of jobs that we need to schedule. So we need to decide two things. First, which resource is going to do what? And second, the sequence. So in terms of the first decision, the allocation, we need to decide whether it's going to be the human or one of the robots to do that, or even if it is a collaboration between the human and the robots. So we have all this flexibility. And then also the sequence of the jobs. So this is a combinatorial problem. It's not a very easy optimization problem. So to approach this problem, we have used different optimization paradigms like mathematical programming, constraint programming, and genetic algorithms. And the best of these methods was able to achieve an optimality gap of 0.7%, which means that on average, we are 0.7% away from the optimal, which is quite close, I would say. So by being able to successfully solve these problems, then we can derive managerial insights for managers. So we can tell them, depending on different parameters, for instance, the robot eligibility, which means the number of tasks that the robot is able to perform. Sometimes it cannot perform all the tasks. So imagine that we have 50% of robot eligibility, and then also it changes depending on the relative speed of the human and the robots. So imagine that the relative speed is 2, we have the black line, and if you can see, if we see the point in the 50% and in the black line, we can read that the improvement in terms of productivity will be 40%. So by generating these types of charts, we are able to inform managers of how much of a productivity improvement they will have in practice. So they can then make their decision of whether, in which cases to invest or not in collaborative robots. So just to wrap up, I think these are the main takeaways of this presentation. Collaborative robots are a very promising technology, and they are a much needed technology because they will allow us to improve both productivity and the human well-being, the human comfort in the shop floor. But we are not still there. We are not there yet. There are still some challenges that we need to address in multiple fields like robotics, augmented reality, machine learning, and operations management. So I would end by saying that robots, I think it's more or less evident from this presentation that robots are not taking away jobs, they are creating them. Because we still need humans in the shop floor to collaborate with robots, we need robots to collaborate with humans, and we need humans also to address all these challenges that we have to face. So, thank you very much.
Thank you for the very clear presentation. Questions from the audience, please.
Hello. Being from Ines Tech and where we have a major competence in natural language processing, have you thought of including in your work natural language processing is to make the humans communicate with the robots and the robots communicate with the humans? Have you thought of that?
Mm-hmm. Actually, I haven't. I'm from industrial engineering, so I do not. The robotics is not really my field of expertise, and this human-robot interaction is not my field of expertise. So I'm not even sure whether someone at Ines Tech is actually addressing that. This is just 10 minutes of presentation, so I try to cover the most important topics, but yeah, thank you.
Another question? You mentioned that there is a limitation, the very reasonable limitation by the time, not yet precise enough, the robots in terms of collaboration with humans, but anyway, there is a good progress. it's a challenge to ameliorate, to increase this precision of movements, I imagine,
Yes.
and the speed to be fast enough in
Yes.
in moving in the red areas.
Yes, yes, right. So, yeah, again, I'm not from the robotics field, but what I can say is that sometimes we have that idea that robots are very fast and they are very efficient, but when we look at the real cases and the real prototypes of these robots, we get a little bit disappointed. They are, in some of the tasks, they are really slow, so in some of the tasks, they might be already in a good enough level, but some others, they still need a lot of work, and this is a big challenge. I think that projection of the next 6 years, this exploding, is a little bit optimistic. At least that's what I sense from my colleagues from robotics. So, yeah, I think there's still a lot of work to be done in that field.
And thank you for your last comment on the last slide on that robots may destroy some work, but they as well create. And this allows me to draw your attention for another thematic agenda elaborated by some of you, like Verbraat, Maria de Maats, and others that may be in the room. Thematic agenda drawn up by the experts in robotics and artificial intelligence, and by experts from the socioeconomic field, experts in economy of work, sociology of work, that work together for a long time. And this thematic agenda will be available within a few weeks, before August, to be at your disposal for discussion and debates across the time. The vision is not catastrophic, as sometimes you can read in the media, that disaster is coming, not necessarily. Even if some allow me, I'm not an expert, but I learn a lot with you, from you, and it's very evident that disaster is not coming in destruction. 50%, as you can read in some titles, in some good papers, newspapers.
Yeah, I would say that there's a lot of help.
And I do not see any other intention to comment. So thank you so much.
Thank you.
And now we move to the fifth communication by Rita Macedo from Instituto de Nanociências and Nanotechnology. It's about nanotechnology in a clean room. If I'm addressing correctly or not, you confirm if I'm simplifying.
Thank you. My name is Rita, and I work at INESCAM and Microsystems and Nanotechnologies. And I'm here to talk about one of the enablers of nanotechnology, clean rooms. And as in other environments, any environment, if you work on it every day, you get used to it. But for the majority of people, clean rooms are intriguing and unknown places. And I hope that that changes by the end of this talk. So microchips are everywhere. They are visible in our phones, in our computers, in robots. But what is not so visible is where they come from and how they look like. They are made in large wafers that can contain hundreds and thousands of microchips. And although the size of a microchip can be as small as a fingernail, they contain inside even smaller features. Here I'm showing a set of sensors that the smallest size is 2 microns. As reference, if you consider a human hair, it has 50 microns, so it's almost 50 times bigger. So we see here the problem. We are trying to fabricate things that are much smaller than the common contaminants in our environments. And even a small particle between 2 metal contacts can ruin a device, can destroy a huge wafer. So to improve the yield, the performance, and reliability of these devices, we fabricate these wafers in clean rooms. So clean room technology is designed to minimize all sorts of contaminants. and therefore it has very strict requirements. It needs air filters to remove very tiny particles. It works under a differential room pressure, so the air can flow from clean areas to less clean areas in a specific direction, top to the bottom. The walls, the floors, and the ceilings are made with using a panel system. Even more, the floor is raised, so the air can flow underneath and escape. Special gowning is mandatory. Temperature, light, and humidity are controlled. And these rooms are full of very specific machines that process these wafers until the final microchip. Clean room follows standards, and these standards specify the number of particles of a given size that are allowed per unit volume inside the clean room. And for you to understand what these numbers means, I made a schematic that shows two types of clean rooms with different standards. And you can see there the number of particles for two different sizes that are allowed. And you can see that for the class 10, we have 10 times less number of particles. So the rule is very simply, the less number, the better. The cleaner is the clean room. Another very important aspect is the dress code. So people are very important in the fabrication processes. However, we are the greatest contamination source for the clean rooms. People produce 75% of the contaminations. For instance, 46% of the particles are released by humans. The numbers are allowed. 10,000 microorganisms is what we have in the per inch square in our hands. And we have 40,000 skin cells. And only sitting quietly, we release 1 million of particles per minute. So you can understand how essential it is to protect the clean room for people. We have to put coveralls, we have to use hoods, boots, and gloves. This ensures that we don't impact negatively in the fabrication process. And as I mentioned before, these clean rooms are full of very important and specific equipment. And I will try using the clean room at INESC to guide you through a fabrication process, through the most representative steps of a fabrication process. Let's start with lithography, when we define the pattern. So for some people, lithography is the core of the fabrication process. It's when we define the design of our microchip. We, in this step, shine an energy source on the surface of a wafer that is coated with a polymer. This polymer is called resist. And the areas that were exposed, they become stronger or weaker, depending on the type of resist, which leaves a pattern behind. Afterwards, we put this wafer in a chemical bath, releasing or dissolving and removing all the, let's say, weaker resist areas. The type of energy source that we use defines the type of lithography technique. At INESC, we have two of these techniques, among others, but two that I'm referring here. One uses a UV light laser, so that is capable of defining features as small as 1 micron, and we have another one that uses a very focused energetic electron beam that can do patterns down to the 20 nanometers. So we see that the laser, or in this case the E-beam, the electron beam lithography tool, enables to do features almost 50 times smaller than the laser. So after removing the resist, we can fill the empty areas with materials. And we have very different machines to do this and that use different techniques. I'll just talk about 3 that we have at INESC. The first one, sputtering deposition. So here we have a camera full of gas, and we promote a plasma, and the ions of this plasma are accelerated towards a target. And by physically transfer of moment, atoms of the target will be removed. So if we place a wafer in the path of these removed atoms, we'll end up with a substrate, with a wafer, with a film deposit. Another technique is ion beam deposition. It's very similar because you also have ions that bombard a target, but here the source of the ions is an ion beam. So the ions are accelerated in a way that form a broad ion beam. The last technique I want to talk about is quite different. It's called plasma-enhanced chemical vapor deposition, and as the name indicates, there are chemical reactions involved. So here, the specimens of the plasma, they are absorbed on the surface of our wafer, and they react, forming the growth of the film and releasing some byproducts in the end. So sometimes we not only need to deposit films, we also need to remove films from our wafers. So this step is called etching. And to do this, we have, again, very different techniques, and I will just talk about two of them. One of them is ion beam etching. So we use the same kind of ion beams. It's on the same machine, but now the ion beam is directed to not the target, as it was before, but the wafer that we are fabricating. And physically, we'll remove the atoms that are not protected by the resist. The other technique is reactive ion etching, and again, there's chemical reactions involved. So inside of these machines, we have specimens that react with the atoms on the surface of our wafer, and ultimately will release them from the surface. Well, to finalize, I just want to mention that INESC MEN is around for more than 20 years. The clean room has been evolving during these years, and the goal is always to follow the technological trends. This sometimes means to buy new machines. For instance, the electron beam lithography, as I mentioned before, allows INESC to work on the nanometer scale and leave the 1 micron scale below. More recently, in the scope of the roadmap for research infrastructures, the micro and nano fabs, we were able to acquire three new state-of-the-art machines to do all the steps I showed to you before, but on 8-inch wafers, so 200 millimeters diameter wafers. So we enlarge greatly the capacity, our throughput capacity. So new challenge will come, and the clean room of INESC MEN will need to be upgraded, not only with new machines, but also with new methodologies and by devising new fabrication process. So thank you, and please, I'm free for questions.
Thank you for the very clear presentation and control of time. Questions, please?
Thank you. You made a very nice presentation on the Portuguese nanotechnology infrastructure. My question is, what is your vision on the importance of these infrastructures to cope with the needs of industry and innovation for Portugal?
Yes, so these infrastructures, these clean rooms are very important on a research level. So sometimes we have new ideas and we need to try them and see if they work. So if you make these clean rooms available for researchers, they will, I would say that these will expedite the time to reach another level of readiness of the technology. So make these infrastructures available for research is very important, yes.
Any other question?
Thank you.
Thank you so much. I pass now before a final period for general discussion, if you want so. I will invite the young from Ciência Viva to make a small intervention. Are you ready? Yes or not? Yes.
So I'm not a Twitter, I'm just a Ciência Viva invited student to make a final comment. So I'm Nelson Rebelo, I'm 19 years old, and I'm currently studying micro and nanotechnology engineering at FCT. And I first came in contact with Ciência Viva through an internship that took me to 2 weeks to CERN, where I got to see the physics and the engineering work they did there. And they are a big example of what big data is and how it's changing our world and how it will change. With 5G, IoT, and other technologies coming along, big data will be ever present in our society. And as this presentation showed, they have a huge potential, if harnessed well through AI and machine learning, to change current paradigms and address problems in climate change, social inequality, and progress as a society. But that progress must always be accompanied with ethics and morals, not to allow a bigger increase in inequality and unfair access to development, which we have seen that in the past and unfortunately in the present defy and challenge our democracies and our progression as a fair and equal society. Currently, I'm working at Ciência Viva and a partnership at E0, and thank you for your presentations and have a good lunch, I guess.
Thank you. Any other comment, general comment from any of the communications, or any remaining question or comment? If not, it was a pleasure to moderate this session from so brilliant communications. Thank you so much. Have a good lunch.